All right, so today we're going to talk about, this is going to mess me up because we're on version 2, module 2, section 15, right? Section 15? Let's say section 15. So this is going to be MongoDB, NoSQL. Note that we're going to specifically talk about NoSQL, or sorry, MongoDB, which is a NoSQL, way to base one approach to NoSQL, but NoSQL covers many, many different things. And generally we say NoSQL, meaning that's called, what's it called? I think it's phrased as not only SQL. So, which is super confusing in my head because I think NoSQL is being like not SQL, but it's not only SQL. So we can use SQL within that. And we'll see all the different kind of ways to approach this. So I have a resource and I'll pull this up real quick. No, as always, it's found in the GitHub repo. That should be in the bottom of your guys's, why is my window not showing up? Oh, there it is. Should be found in the bottom of the Learn doc and everything. But I might just so you guys know, I might reorganize this repo because we're going to talk about version 2. And I noticed that some of the stuff I have doesn't match up with the version 2 curriculum numbers. So like, for example, this is like under the module 2, which works fine, but some of the stuff later on is actually gonna be part of module 3, which is super confusing. But anyway, just kind of know it might change up. But we're gonna specifically talk about NoSQL, and we're gonna talk about NoSQL intros. So let me minimize this part. Okay, so and cool, I see Andrew joined us, awesome. So, first I want to talk about like NoSQL. So we kind of talked about SQL to begin with. Like, I mean, we started off with SQL, right? I think a few sections ago, earlier in mod 1. And so SQL, just know is that it's a relational database, right? And when we say relational database, it really means tabular data. So everything's formed around tables. So we kind of imagine this when we talk about pandas, we talk about, doing data frames and such. We're talking about tabular data. And really, it's really great because, it's really useful because it's structured. You know what the table looks like. Basically, you structure the table and then you insert the records into rows, right? Straight up. Hopefully that feels pretty, nothing new to you guys, right? So it's really nice because it means that we haven't really talked about this, but basically there's different ways you can implement SQL servers. So everyone has a little bit slightly different. For example, there's MySQL. For example, I've used before DB2, which is an IBM implementation. There's other basically ways to implement SQL, but what's nice is that SQL is not really like a programming language like it is Python. It's really called a command language, where basically you're saying to the server, like in the SQL format, say, hey, I want these things, give me these things. And the server basically decides on how to actually execute those parts. And so the server is actually doing all the work versus you actually performing the work on your own like code and stuff like that. So what's nice is that it can be super versatile, but like it's always the same. You can basically more or less use the same SQL commands no matter what structure you're using. And it's pretty much understandable no matter what structure. But it's also really restrictive because it's forced to be in this tabular format. And we saw like XML and JSON when we did like APIs and when we did, I think the first discussion of JSON and XML, that these, those formats don't really have don't necessarily have a tabular format. And when you have things like that, then you kind of have to play around with it to get into a nice format. And so basically, especially as data grew larger and larger, SQL wasn't really enough like to encompass all the different forms of data that it can take. For example, there used to be, I mean, we still talk about them now. It's not like, I say used to, but just know that doesn't mean that it's out of practice. It's just that there's different ways we can apply these kind of, what's it called? We can apply these, I lost my train of thought, sorry. But like when I say they're older, it doesn't mean that like they're out of use. It's just that we have newer stuff that might be more relevant to what we use. But know that SQL and relational databases in general are still used today and are still very useful depending on the situation, okay? That brings us to NoSQL. And so, that's what I was talking about. We have things like data warehouses. You might have heard data warehouses before. And data warehouses are basically like, you can think of it like a lot of old school like structure, and this is more the data engineering side of things. But basically you have these data warehouses and stuff, and they're very structured where essentially you have all very tabular information. It's organized in this very like already known structure. Then you start having these things recently, which are called data, like they're called data lakes. And data lakes are kind of like, you just put a bunch of data within this big lake, and it might not be structured. Some of it's structured, some of it's not structured. You have images, you have, you know, data and stuff like this. So SQL servers don't really do a good job with things like images or varied structure. Like it's not really meant for that. It's meant to say, all right, here's your structure, and you insert the tables in there. So you have to know what your scheme is ahead of time. So this brings us into not only SQL or NoSQL, okay? And so NoSQL, okay, really they're usually called non-relational databases. Note that sometimes they're called distributed databases. But that's not really, I think that's not a very good accurate term, because a non-relational database doesn't have to be distributed in the way that you would think distributed computing. But no, when we say distributed, what means like, okay, basically it's not all on one server itself. Now, NoSQL doesn't necessarily have to be there. It could be one server. But really a more accurate term is saying they're non-relational. Basically, it's saying that you no longer have like a column and a row structured in that way, okay? So note that I kind of put this little link right here, is that there's a good resource of like how NoSQL and SQL are similar and different. So for example, we have our SQL, so we have our tables, our rows, our column. We talk about primary key. Hopefully this is kind of bringing up some memories of like how SQL would work, right? And there's some other stuff you might not have talked about, like for example, we didn't talk really much about view, but the idea is still there essentially. So a lot of these things are the different concepts in SQL itself. And then you can see here are basically some different structures. For example, we'll talk about MongoDB, but there's other different structures and different NoSQL databases that we can actually use, okay? So for example, for MongoDB, our table is going to basically be a collection, right? It's not going to be just be called a table. Our rows, which is kind of like, you think of like, sometimes we'll say row or record, like especially if you do Excel, sometimes we'll talk about records, really you're just talking about a row. Our records are going to be replaced, or our rows are going to be replaced with documents, right? And then we have our columns, which are really like more like fields. And what this allows you to do is essentially make different structure and varied structures and stuff like this, and more flexible structure. So that's the real reason why we use NoSQL. So our advantages, like I said, is that we don't need to have the structure. We don't need to know what it looks like ahead of time. If all of a sudden, like for example, like let's say you have a SQL table, like your own table and everything like this, and you have it for, let's say, I don't know, let's say for students, right? And you say, okay, there's a student name, there's, let's say, something, their age, and then there's something like, I don't know, where they live, right? So those are like 3 different columns of SQL. And then all of a sudden you was like, oh wait, you know what? Like now that we have enough students, we really would like to like track like their grade point average. Well, that means you'd have to create this new column and everything like this, and you kind of have to basically you have to reformat everything, and it's kind of a big bit of a pain. But with NoSQL, you can really easily add this attribute onto the records and stuff like this. So this makes NoSQL really flexible. It's specific to the database. It doesn't have to be the same structure every single time. We'll talk about a few examples of how to what this would look like. Also know that it's something called horizontally scalable. And so you might have heard this, for example, like spin up a new server. When we say spin up a new server or spin up, if you ever hear that term, basically it just means like to create a new server. So you might have multiple, and you can think of a server as a computer. So this is what the cloud really is, right? So like you can kind of think is that when we talk about like the cloud or like, you know, servers, it's like you have a server right here, and then like you might spin up a new one and stuff like this. And basically these ones might share information across each other. And so this is kind of distributed part. With SQL, you essentially have one server. And if you're a computer, if you want any information, you always have to ask this one server. Okay, that's kind of how SQL is formatted. If you, for example, this is more for web-based stuff, but if you have something that's really far away and you have, like to say that's all the way over across the, you know, into another country, right? It might make more sense to actually have another, instead of you having to connect all the way over here, it might make more sense for you to connect directly to this part. Well, you have to have essentially a copy of that same server going back and forth. So you can imagine that if you change one part in here, you have to make sure that this gets sent over to this side and stuff and keep this updated. So these are basically copies in order for you to have multiple servers. But the main idea is that the SQL server, like we've been talking about, lives on one computer essentially. With NoSQL, you actually can have multiple servers that share information. So for example, is that if you want your database to be, if you want to improve your database, you can just basically put in a new server into it. And so basically, if you get more and more servers, you essentially split up a lot of the resources versus having one computer handle everything. You can say, okay, well, I only want to ask this one guy right here and get all this information and put this in. And I'm saying this in a very general sense because we're going to talk more about this, especially in the future. Like I'm thinking like module 4, you know, kind of deal, maybe even module 5, where we'll talk about distributed computation. But just know basically is that like this is what we're doing. We're essentially allowing to split up the resources so you don't have to rely on one like monolith SQL server. With NoSQL, you're allowed to be distributed, where you basically can talk to the different servers. And if one server goes down, like this one like loses power or something like that, or no longer connected to the internet, all your data is not gone. If this one guy goes dead, you better hope you had a backup somewhere that's going through. But with NoSQL, you're allowed to basically have a little bit of like redundancy. Okay, so horizontally scalable really just means like if we want to make it faster and better, we just basically add a new server. Just for comparison, SQL is vertically scalable, which basically means that in order to increase your speed, or let's say like, oh, like we're running like low space on the server, you basically have to upgrade that one server. You have to get new hardware or new RAM, or completely migrate the whole copy to a new computer with better hardware. With NoSQL, you can basically just add the same smaller servers, and essentially it would improve it at that point. Okay, so those are some advantages and such, and like how you would approach NoSQL. Any questions so far? Okay, sound pretty good so far? Okay, cool. So, and I know that I kind of talk in general, so it's not like it was super like detailed in that way. But some example systems. So MongoDB is what we'll be actually using today. I think that's what we'll focus on the course. But no, that's not the only way we can do NoSQL. For example, there's Google's Bigtable. I think let's see, I know Nicole had signed up for it. If anyone's doing the SQL summer camp with Kaggle, it's just launched like this week or something like that. They're using Google's Bigtable, for example, using that structure. I think, or maybe it's Bigtable. Maybe I thought it was Bigtable, but maybe it's BigQuery. But basically, the idea here is there's another structure. There's also AWS's AWS, by the way, is Amazon Web Services. So this is Amazon. DynamoDB, another example system, and then Apache Cassandra is another system here. So these are basically other ways you can think of like equivalent to SQL servers, but for NoSQL. Okay. So this kind of comes out like, okay, cool, these are some examples, but like, how do they actually work and how do they actually do anything? So they all have different data models. So basically NoSQL is kind of like the other term. Like, it's kind of like, oh, it's just not just SQL, it's other things. So we have, for example, the curriculum talks about a couple other ones, but basically there's document stores, okay, there's key value stores, and there's graph databases. And I think, do I have the resources here? Maybe I don't. Oh, sorry. I thought I put it in here, but maybe, oh, no, okay. I thought I put the resource here, but maybe it's on here. But basically know that there is a really great documentation just kind of introduce this on AWS's website. Talks about like key value, document, graph. There's a few other ones that we're not going to talk about. There's a few other ones, like for example, the curriculum talks about column stores, which are really similar to document stores. So we're not going to make that difference, but it's basically the same thing. And they basically show you the different, like, what these look like and kind of explain the use cases and such. So just kind of know that's there. But the first one we're going to talk about is document stores, which is what we're going to use for MongoDB. So MongoDB is a document store. And basically, instead of having, like, if you imagine in a SQL database, oh, do I have a little drop in? Oh, that's not what I wanted. Oh, well. Sorry. So if you imagine back when we had like, SQL, we have our table, right? And we have our different columns, okay, and our different rows and stuff like that. And it's basically to like look up the information, you essentially would find the column, right? And say like get all the rows, and you might do like where clauses and say, oh, only get these specific rows, that have like, age is equal to like 3 or age is greater than 5 or whatever it is, right? So document stores basically, it stores information in a document itself. And you can imagine this table is replaced with a document. And so in this document, there's information in here. And within this, it's kind of nice is that it basically keeps it semi-structured. So in this document, you have a certain structure of like what can be in there. So you can kind of think like, what's it called? Like, this is kind of similar to like, we'll see like a dictionary, is that MongoDB kind of uses the equivalent to like dictionaries in here. And so basically you can source like, okay, well, this key and this, value right here goes within this document, but then each document can have a different structure. So what's kind of nice is that you don't have to actually have the same structure as a SQL part. And it also makes it hierarchical. So basically you can have documents pointing to other parts, and you can basically structure these parts differently, where SQL basically only uses like tables that can join into tables based on primary or what's the other? Primary keys or, oh shoot, I'm blinking out right now. But basically keys that can reference into other tables and stuff like this, okay? So that leads us to document stores, which we'll mostly focus on today, okay? And you'll see kind of this difference later. The next one basically is our key value stores, which I kind of mentioned a little bit. Basically here is that we have our partition, basically like, you can think of, we're not gonna use this today, but like basically you think of the data is more partitioned and it's different blocks of data. And it uses something called a hash table. Does anyone know what a hash table is by chance? Has anyone heard that term before? Okay, so you'll hear this a lot more, but hash table, if you were to say, what is a hash table? Think Python dictionary, okay? Is that basically you have like a key, like which is like in a dictionary, like, okay, what is my key? And then the value afterwards. And what's nice about hash tables is that it's very quick. Basically, it's like once you have that value, you essentially can go right to the data versus if you had a list of data. So for example, if I had like a list of data, right? Or like mostly array, right? But if I had like a list of data with information and I would say, what's the maximum in here? Okay, I'd have to go look at every individual one like this right here, or look for a specific part. A hash table or like think of like dictionary. Basically, once I know the value, I can go straight to whatever I want. So this can be very efficient, very quick, and it works well when the data is partitioned or highly partitionable. So basically allows you to like put this into different parts and stuff like this. So just know that there's another structure here. And like I said, there is some great documentation right here. For example, key value. Okay, and kind of talks about the different use cases and stuff like this. So if you want to get, like, this is more data engineering side, is that just know there's different kind of aspects and you can explore more. And I think the curriculum talks a little bit about it too, but no, there's plenty of resources you can learn about this, okay? And then graph databases is another one that the curriculum mentions as well. It's for highly connected data sets. And the important part is that it's not storing it's storing the information, but the thing that's really important, the way it's structured, is it keeps the relationships. It basically is storing the relationships so you can detect the stuff. So this is really useful for like social networking, right? So different graphs of like social networks. This is directly from Amazon's AWS website up here. But recommendation engines, knowledge graph, think like, like Google search and stuff like this, what things are related to each other. Fraud detection is an really interesting one. Does anyone have an idea like why graph databases might be really useful for fraud detection? Anyone got a guess on that? Especially when I say relationships first. That's right.
Maybe if you're connected with someone who's committed fraud, that makes you more likely to commit fraud.
It could be something like that. So like maybe you are connected. That would be like more social graph. One thing could do too, it's not so much about, what specific action you did, but also might be the patterns of behaviors and stuff and other relationships that you had. Like, like maybe you're doing specific things or certain actions and transactions that are fraud detection kind of thing. So what's nice is that because it puts relationships first, you can detect some of these relationships that would basically that would be suggestive of fraud. So again, this is one of the reasons why, you might use a database like this. And what's nice is that these things like putting, relationships first, making it more like a key base, where the data is much more like saying like, what a key and then the actual value, or a document store where you basically have a lot more flexibility within the data itself. This NoSQL allows us to do stuff that's not tabular based, okay? So those are some different kinds. I just want to kind of show those things. And you can read more about them in the curriculum, or what I'd really suggest if you really want to know more about them is to actually check out that resource or other resources, right? So this is a really great summary of a few products that AWS does and different ways they use NoSQL, okay? This leads to my last part for NoSQL, and the curriculum talks about like fault tolerance and resilient distributed databases, which is a huge mouthful. And just know for data engineering, if you ever dive deep into data engineering, there are acronyms galore. Like there are so many acronyms. So just kind of be aware that if you start seeing all these acronyms and you're like, what's going on? It's because it's just the terminology they have. But you can kind of hear the fault tolerance, resilient distributed databases. Basically, the idea here is that we keep our databases separated out. And so you can think of like resilient distributed databases, RDDs. We have multiple servers. Oh, I put servers, it should be servers. Okay, so multiple servers. And the idea here is that like, I don't know if you ever heard this phrase, 2 is 1, 1 is none. Basically, it's like if one server goes down, you got a backup. Okay, so you know that basically like in the SQL structure, if that server goes down, you better have a backup. But what's nice is that with resilient databases, for example, talk about like Hadoop and Spark, those structures are basically built across where you can essentially have multiple copies in different places. So I kind of put this on like copy paste, right? Twin. So basically the idea here is that if you lose one, you're not going to lose the whole database. You have other copies other places. And so what's kind of cool is that this allows you to build fault tolerance. So like if a server or something happens to a server where it crashes or it physically gets damaged in some way, and this is actually a really interesting part, with very, very large data sets, for example, like Google, who has like, you can imagine a huge amount of data. They have so many hard drives. I think xkcd.com, which again is always relevant to us. I did a little calculation thing and basically trying to figure out how many servers they have. And one little side calculation you ended up finding was that like how often their hard drives probably fail, because hard drives have a percentage of failing every once in a while. And a server really is just a computer. And so you expect the hard drive to fail every once in a while. Well, Google's has so many probably like data itself is that it has to calculate like the fact that the hard drives are going to fail constantly. And it's something like every, I want to say it's like every like less than a few hundred seconds that a hard drive will fail, considering how many like hard drives they have. And so they have to constantly think about, you know, like, well, our hard drive will fail just out of pure chance. So we have to kind of consider this kind of thing. So this is a real issue with big data, saying, hey, we need to make sure if something fails that all the data is not gone. And so I kind of put this right here. Udacity has an intro course to Hadoop, which is free. Again, I'm not expecting you guys to go do this right now or anything like this, but something to kind of keep in your belt too, especially if you're curious about some more data engineering aspects. But basically, you can kind of see here, this was directly taken, I think, a screenshot from Udacity itself. I think it's from their YouTube video. But you can see here, you can imagine this red, green, and blue. You can think of like the whole database being like the red stuff, the blue stuff, the green stuff. And basically what happens is with like Hadoop and other ones that are RDDs, basically what is that they split up this data. So that way, in case like, let's say, for example, this one database fails right here. Well, it's like, okay, we lost the green and the blue, but we can see there's still green, there's still blue, there's still red in the different databases. So you don't, even though if you lose one server, you still have copies, but you don't have to make a full copy of everything. So what's kind of nice is that it does allow you to, one, make a bunch of copies, but two, do it efficiently, where you're not having to make literally a whole copy completely over. Like you don't have to copy a whole copy of like, you know, red, blue, green, and then also make another one, red, blue, green, which would technically treat us in part, but if I instead split it up, we're like, okay, where I have some of it's in red and green here, some of it's green and blue over here, blue and red over this way, basically kind of split up that data. So if one fails, the other two can pick up the slack, okay? And again, like I said, Hadoop and Spark are two parts. Note that Spark is considered kind of like the newer like Hadoop. They're both by Apache, they're both open source, but basically just know that there's a difference, there's a slight difference in like how they work. Spark tends to be faster. We'll actually use PySpark later on in the course, but basically just know it's a distributed system. They're built kind of similar from each other. You'll still come across Hadoop. Most of it is because it already exists. So for example, Facebook uses Hadoop, even though it's kind of older. It works well enough where really they could technically move to Spark, but it'd take more effort for them. So they're fine basically sticking with Hadoop. So you'll come across this, especially with well-established. But if you're coming across like a new, like a startup or a new company in the past like 5 years, they're likely going to try to use Spark because it's just a newer technology and it's a little more efficient and faster. But one concept here, and I'm only bringing this up really briefly, is with the data all separated out like this, the problem is that you can't just go to like a SQL server and ask for, like, give me all the records of someone who's over, let's say over 25, right? And so you can get all the records from one SQL because it's all the information. But if I went to this one server right here, I would have to say, hey, like little server right here, tell me everyone who's over 25. Well, it only return the stuff that's from red and from blue, but it'll miss all the blue data, right? I'm sorry, red and green, and then it'll miss out the stuff from the blue because I'm only asking this one little server. So what Hadoop basically is in MapReduce allows you to say, all right, each server calculate this stuff on your own stuff. So it's like, oh, find everyone who is over 25 on your server, find everyone who's over 25 over on this server, and then send that information essentially all at once. So that way, you basically will get all the information, but it's done on a distributed system, basically on multiple computers. So no, there's a slight difference on how that works. And there's some reasons why we actually want to use this, but I won't go into more detail about that. So that was very quickly an overview of NoSQL and its differences and how it relates to SQL in general. Any general questions at all about stuff I went over? All right. Well, thumbs up, sideways, thumbs down. How are we feeling? All right, cool. Thumbs up, some sideways. Yeah, it's kind of tough to not like without showing you like it's like, oh, this is how NoSQL works, and then actually going into it. So I really suggest is that just know this is a huge aspect of it. Like I mentioned, data engineering. This is basically what data engineers would focus on. Say what's the best kind of way to store this information and the advantages and disadvantages for speed and such and all these things. Which as a data scientist, you can pivot directly into data engineering if that's something that's really interesting to you. But at the very least, you'll touch it at some level, interacting with different database and different data structures. All right, cool.